Hello everyone, welcome to the another lecture on carbohydrate. In this lecture, we most of time discuss on the open chain structure of carbohydrates, especially open chain structure of monosaccharides. Before we discussing the open chain structure of monosaccharide, first to understand the DL notation system for carbohydrates. Carbohydrates generally containing more than one chiral carbon atom and their stereochemistry we can easily explain or easily understand with the help of Fischer-Position formula. In this Fischer-Position formula, the D and L prefixes specify the configuration at the carbon atom that is second from the bottom. So we say that the DL notation are very useful for carbohydrate, in which if you want to describe the stereochemistry of the second carbon atom from the bottom in Fischer-Position formula. Generally in the Fischer-Position formula, the more oxidized group is present at the top, whereas least oxidizable group present at the bottom in vertical line. In case of carbohydrates or monosaccharides, the carbonyl group is most oxidized, and therefore this carbonyl group is either present at the top or near the top in Fischer-Position formula, whereas last achiral carbon atom, that is CH2OH group, is present in the bottom in the Fischer-Position formula. In the Fischer-Position formula, if the hydroxyl group is present right hand side, then it is a D isomer. For example, if you take this is the one example of the 4 carbon containing monosaccharide, that is called as the erythrose. In this formula, we observe that the most oxidized group, so in case of aldehyde, is most oxidized group in the carbohydrate. So this is the most oxidized group which is present at the top in the Fischer-Position formula, whereas least, that is this CH2OH group, is the achiral carbon or achiral group, so it is present at the bottom in the Fischer-Position formula. So DL notations describe the stereochemistry of the second carbon atom of carbohydrate in Fischer-Position formula. So generally if you give the number to the carbohydrate, so numbering is always start from the top carbon atom. So this is carbon number 1, carbon number 2, this is the carbon number 3, this is the carbon number 4. But we want to carbon number second from the bottom. So this is the bottom carbon atom, and if it is the first carbon atom, then this carbon atom, this is the second carbon atom, and if this second carbon atom having the OH group in the right hand side in Fischer-Position formula, then this isomer is described as D isomer, and therefore name of this compound is D erythrose. If you take its isomer or enantiomer, in which the hydroxyl group is present on the left hand side, is known as L isomer. For example, this. So in this Fischer-Position formula, we find out that the second carbon atom from the bottom and in this second carbon atom, this OH group is oriented on left hand side, and therefore this is the described as L isomer. So this is the example of L isomer. So this is the L isomer. Okay. So we understand that this is a very simple thing. We look at the second carbon atom from the bottom in the Fischer position formula, and if OH group on the right hand side, then it is called as the D isomer, and if the OH group is present on the left hand side in the Fischer position formula, then it is called as the L isomer, and therefore the name of this compound is L erythroids. Next point we discuss in this lecture, that is the open chain structure of monosaccharides. The monosaccharides are the two types depending upon the function group, that is the aldose and ketones. So if monosaccharide containing the aldehyde is the function group, then it is called as the aldotes, and if monosaccharide containing the ketone as the functional group, called as the ketones. First we discuss the open chain structure of the aldotes. In case of monosaccharides are further classified into different types depending upon the number of carbon atoms. Generally, in case of monosaccharide, the number of carbon atoms varying from 3 to 9, and therefore there are sub-classified as tetrodes, pentodes, hexodes, heptodes, etc. First we discuss the open chain structure of the 3 carbon containing monosaccharide, that is called as the aldotetrons. So name itself indicates that this is the combination of the aldehydic function group having 3 carbon atom chain. Okay. So in this aldotriads, so trios indicate that 3 carbon atom carbohydrate, and first that is aldo indicate that having the aldehyde function group. So it is a one type of aldones. So this aldones containing the 3 carbon atoms, and their formula is CHO, CHOH, CH2OH. And in this formula we observe that the second carbon atom, so this second carbon atom is the chiral carbon atom, because this carbon atom having the 4 different groups. First one is the aldehyde function group, the second one is the hydrogen, third one is the OH, and fourth one is the CH2OH. So this carbon atom having the 4 different groups, and therefore this is the chiral carbon. Okay, and we can say that this aldotriads having one asymmetric carbon atom or one chiral carbon atom. Therefore, according to the one top rule, the number of stereoisomers are possible is equal to the 2 raised to n, where n indicate the number of asymmetric carbon atom or chiral carbon atom present in the molecule. So in case of aldotriads, the number of chiral carbon atoms, that is n, is equal to 1. Therefore, there are 2 stereoisomers are possible, that is 2 raised to 1 is equal to 2. And we observe that these 2 stereoisomers are non-superimposable mirror images of each other. Therefore, they show the one pair of enantiomers, that is the D and L isomer. If we draw the structure of this, then again we observe that in this Fischer position formula, the aldehyde group is placed at the top and CH2H group is placed at the bottom, and therefore this is the second carbon atom, and in this OH group is present on the right hand side, and therefore it is the D isomer. Okay, and name of this structure, it is the D-glyceraldehyde. If it was the another structure of this, that's exact non-superimposable mirror images in which OH group present on the left hand side called as the L-glyceraldehydes. The second type of the Aldo sugar, that is the Altotethrus. So Altotethrus having the 4 carbon atom, out of which the 2 chiral carbon atom present in this molecule. So this is the carbon number 2 and 3. These 2 carbon atoms containing 4 different groups, and therefore these 2 carbon atoms are chiral carbon atom, and therefore according to the one-top rule, the number of stereoisomers are possible is equal to 2 raised to 2, that is 4, and these 4 stereoisomers exist in the 2 pairs of enantiomers, that is the D and L. So if we observe the first structure, in this structure both OH group present on the right hand side, and therefore it is the erythroisomer. In this erythroisomer, the second carbon atom in which OH group is right hand side, so this is called as the D isomer. So name of this compound is D-erythroids. In the second compound, it is a mirror image of these erythroids in which both OH groups present on the left hand side, and the second carbon atom from the bottom in the Fischer position formula is left hand side. So this is example of L erythroids. So in this both structure, we observe that both OH groups present on the either side, either right hand side or left hand side. If we take the third structure of this, then we observe that the C2 carbon atom. So if you give the number to this Altotethrus, then the numbering is start from the top in the carbohydrates. So the aldehyde group having the first carbon atom, though this is the second carbon atom, this is the third carbon atom, and this is the fourth carbon atom. So in this structure, the C2 carbon atom having the OH group on right hand side. Okay, and this structure it is called as the 3 O's. Again in this structure, from the bottom, the second carbon atom in which OH group is right hand side, therefore it is the D isomer, and therefore name of this compound is D3Os. If we take its mirror image, that is the fourth structure, so this is the second pair in which we observe that the third carbon atom having OH group on the left hand side, whereas second carbon having OH group on right hand side. Okay, so this is the another structure, and in which again we observe that the second carbon atom from the bottom having OH group on left hand side, and therefore this is the L isomer known as the L3Os. The another type of the aldos, that is the Aldo Prandtls. So name itself indicate that containing the 4 carbon atom, In this 4 carbon atom, if you use the number, that is 1, 1, 2, 3, 4, 5. So again we observe that carbon number 1 is the aldehyde group, but carbon number 2, carbon number 3 and carbon number 4 are asymmetric carbon atoms because they bearing the 4 different groups, and therefore the Aldo Prandtls having the 3 asymmetric carbon atom or chiral carbon atom. Therefore, according to the one top rule, the number of stereoisomers are possible is equal to 8, and these 8 stereoisomers are exist in 4 pairs of enantiomers, that is the D and L isomers. The configuration of 4D series Aldo Prandtls are shown in here. So first one is this compound. It is called as the arabinose. If you give the number to this structure, again we can start from this aldehyde group. So it is a top carbon atom. So it is 1, 2, 3, 4, 5. Okay. So carbon number 2, carbon number 3 and carbon number 4. These 3 carbon atoms are asymmetric carbon atom and having OH group, and this all OH group present on the right hand side. Then this structural isomer is called as the ribose. Again in this series we observe that this OH group present on the right hand side in Fischer position formula. So this compound or this structure it is called as the D-ribose. So in case of arabis, the all OH groups present on the right hand side. Then the next stereoisomer is arabinose, in which the second carbon atom having the OH group on the left hand side. The third, in which the third carbon atom OH group on the left hand side. Fourth structure is possible, in which the carbon atom from 2 and 3, in which both OH groups are present on the left hand side, called as the lysis. Okay. So if you give the number from carbon number 1, 2, 3, 4. Okay. So we do not change the stereochemistry of fourth carbon atom because this is the second carbon atom from the bottom, and we can draw the structure of D isomer. So D isomer मध्ये काय आहे? The second carbon atom from the bottom, their stereochemistry does not change. Okay, and remaining OH group we can rearrange. So we observe that first structure both OH groups on the right hand side. In second, the second OH group on left hand side. Third one is right hand side. Third structure मध्ये काय आहे? The second carbon atom having the OH group on the right hand side, and third carbon atom OH group on the left hand side, and in fifth structure both OH groups present on the left hand side, but the position of fifth group or position of third OH group does not change, so it is always present on the right hand side. Then only it is the D isomer. Okay. The L series will be the corresponding mirror image of this compound. So these are the 4 D isomer, and remaining 4 are the L isomer. If you take the mirror image of these D isomers, we get the L isomers. For example, this. So this is the structure of the D series, and if you take the mirror image, so if you take the mirror image of first, okay, so this mirror image is similar to this compound. Okay, so this ribose having the mirror image, that is again ribose, but the second carbon atom OH group on the right hand side, so it is a D isomer, and in this case the second from the bottom, the OH group on the left hand side, and this two, therefore this is the pair of enantiomer, that is DL pair. So this is the first DL pair. Similarly, if we take the mirror image of arabinose, we get the its L isomer. So this is the second pair of DL pair or enantiomer. Similarly, if we take the third mirror image of xylose, so we get this. So this is the third pair of the enantiomer, and if we take the mirror image of D-lysose, then we get the structure of L-lysose. So this is the fourth pair of enantiomer. So we can observe that the number of stereoisomers are exist in the DL pair. Okay. So if there are DL pair are 4, that indicate that there are formation of 4 D isomers and 4 L isomers. The next Aldo carbohydrate is Altoh Exosis. So Aldo Exosis. So this Aldo Exosis having the 4 achiral carbon atom or 4 chiral center, which are present on the carbon number 2, 3, 4, 5. And if we draw the Fischer position formula, so again aldehyde group is present on the top, while CS2H group is present on the bottom in the Fischer position formula. So this Aldo Exosis having the 4 asymmetric carbon atom or 4 chiral carbon atom. Therefore, according to the Von-Top rule, the number of stereoisomers are possible is equal to 2 raised to 4, so is equal to 16. So these 16 stereoisomers are existing 8 pair of enantiomers, that is the D and L isomers. So the configuration of 8 D series Aldo Exosis are given below. Okay, so this is the first structure of Aldo Exos. So in which we can observe that the carbonyl group is the top and CH2H group at the bottom. So if we give the number, so this is the carbon number 1, this is the carbon number 2, this is the carbon number 3, 4, 5 and 6. So out of which there are the 2, 3, 4, 5 carbon atoms are chiral carbon atom, therefore 16 structures are possible. Okay. If you want to draw the structure of the 16 isomer, then there are the 8 DL pair, okay, and therefore we can draw the series of D isomers. So we can keep the stereochemistry constant of second carbon atom from the bottom. So draw करताना काय करायचे, जो सेकंड कार्बन ॲटम असेल त्याची OH ग्रुप काय करायचा, कायम राईटला ठेवायचा, तो चेंज करायचा नाही. अँड रिमेनिंग 3 ग्रुप्स, जे रिमेनिंग 3 OH ग्रुप राहिलेले ते काय करायचे, इंटरचेंज करायचे. सो इन द फर्स्ट 4 compound, in the second the structure it is called as the D altoths, in which the second OH group on the right hand side. In third structure that is called as the D glucose, in which the OH group of third carbon atom, sorry the mistakenly OH झालेलं आहे, so this third OH carbon atom चा OH group काय असतो, right hand side ला असतो, सॉरी लेफ्ट हँड साइडला असतो, Then the another is D manus, in which the 2 and 3 OH group present on the right hand side. So in first 4 structures we observe that we never change the conformation of C4 and C5 OH group, so that are remaining constant. So first one is the D-allose, D-altrose, D-glucose, D-mannose. So structure देणार series मध्ये देणार आहेत allose, altrose, glucose, mannose. In this structure, the C4, C5 OH group on the right hand side, and remaining 2 OH group we can alter. So allose मध्ये दोन्ही OH group काय आहेत right hand side ला आहे. altrose मध्ये second OH group right hand side ला आहे, sorry second left hand side ला आहे, third right hand side ला आहे, fourth third मध्ये सॉरी इथं काय आहे OH आहे, इथं काय आहे हायड्रोजन. Okay, so in case of allose, altrose, glucose and mannose, in this 4 structure the C4 and C5 chiral carbon atom does not change their stereochemistry. So प्रत्येक वेळेस हे काय असणार आहे, ह्या दोन्हीचे पण OH ग्रुप काय असणार आहेत राईट हँड साइडला असणार आहेत, आणि उरलेले जे 2 OH ग्रुप आहेत that we can change. In first structure allose, both OH group on the right hand side. In next C2 is left hand side, C3 is right hand side. Next C2 is right hand side, C3 is left hand side, and last both OH group on the left hand side, that is the mannose. So allose, altrose, glucose, mannose. So in this way we can understand the structure. So allose, altrose, glucose and mannose, we can memorize their series and think in mind that the C4, C5 OH groups are right hand side in this structure, and remaining 2 will be alternatively changed. The next series, the structure is this. In this time we can change the position of C4 OH group. So that is the D glots, in which the C4 OH group is left hand side and remaining are right hand side. So in this series, so in this remaining 4 structure, we observe that the C4 OH group on the right hand side and C5 OH group on the left hand side. Okay, so ज्यावेळेस तुम्ही दुसरे 4 स्ट्रक्चर काय करता ड्रॉ करता, सो वी कॅन कीप इन माइंड दॅट दिस काय त्यानंतर यायचंय का C4 OH ग्रुप काय लेफ्ट हँड साइडला आहे आणि C5 OH ग्रुप काय right hand side. So this kept in mind. Okay, and then again the remaining 2 OH groups are, first they are same side, the next structure the second OH group on the left hand side, third one is OH on the right hand side. Next structure the second OH group is right hand side, third on the left hand side, and fourth both OH group on the left hand side. So name of this compounds, namely that is the D-glucose, sorry D-glucose, D-iodose, D-galactose and D-tannose. Okay, so structure कसे त्यानंतर यायचे, the simple way that पहिले 4 स्ट्रक्चर मध्ये काय आहे, जो तुमचा C4 आणि C5 चा OH ग्रुप आहे ते दोन्ही पण काय असते राईट हँड साइडला असते, आणि उरलेले 2 OH ग्रुप काय करायचे ते अल्टरनेटिव्ह चेंज करायचे. नंतर पुढच्या 4 स्ट्रक्चर मध्ये काय होतं, C4 जो असतो सो C4 चा OH ग्रुप काय येतो, लेफ्ट हँड साइडला येतो एव्हरी टाइम, आणि C5 चा OH ग्रुप काय असतो, राईट हँड साइडला असतो. आणि उरलेले जे दोन OH ग्रुप आहेत ह्या दोन्हींचं काय करायचं, इंटरचेंज करायचं. सो फर्स्ट दोन OH ग्रुप राईट हँड साइडला, नेक्स्ट C2 OH ग्रुप लेफ्ट हँड साइडला, नेक्स्ट C3 OH group on left hand side la, and next that is fourth one both OH group that is C3 and C2 and C3 both on the left hand side. Okay, पण हे ध्यानात येत असताना ही जी सिरीज आहे that is will be remember that allos, altos, glucose, mannose, glucose, idos, galactose and talose. So ही नावाची सिरीज काय पाहिजे, ध्यानात पाहिजे. आणि स्ट्रक्चर ड्रॉ करताना कशा पद्धतीने ड्रॉ केलेले ते पण ध्यानात आले पाहिजे. सो पहिल्या चार स्ट्रक्चर मध्ये काय केलेले आहे, C4 आणि C5 चा OH ग्रुप काय आहे, उजव्या साईडला आहे, आणि उरलेल्या चार स्ट्रक्चर मध्ये C5 OH ग्रुप डाव्या साईडला आहे आणि C5 OH ग्रुप काय आहे, उजव्या साईडला आहे. आणि उरलेल्या दोन स्ट्रक्चरचं काय केलेलं आहे, इंटरचेंज केलेलं आहे. कसं केलेलं आहे, पहिल्या स्ट्रक्चर मध्ये दोन्ही OH ग्रुप काय आहेत, राईट हँड साईडला आहे. दुसऱ्या स्ट्रक्चर मध्ये जो C2 चा OH ग्रुप आहे तो लेफ्ट हँड साईडला येतो. तिसऱ्या स्ट्रक्चर मध्ये C3 चा OH ग्रुप लेफ्ट हँड साईडला येतो. आणि चौथ्या स्ट्रक्चर मध्ये काय आहे, C2 आणि C3 हे दोन्हीचे पण OH ग्रुप काय ते लेफ्ट हँड साईडला येतात. ओके, सो इन दिस वे वी कॅन ड्रॉ the eighth structure of D series compound. If you want to write the structure of L series compound, then we can take the mirror images. Okay, if we take the mirror image of D allos, then it is called as the L allos. If we take the mirror image of D altos, we get the L altos. If we take the mirror image of D glucose, we find out that is the L glucose. If we take the mirror image of D mannose, if we get the structure of L mannose. So in this way, remaining the 8 hexose, Aldo Exosis structure we can draw. Okay, so this is the open chain structure of Aldo Exosis. So Aldo Exosis having the 16 structure, out of which 8 are the D and 8 are the L. Then we discuss the open chain structure of ketones.